Hi there. Well, we're going to look at 1.7 and 1.9, and 1.7 is where we're going to start solving equations. And an equation is something with an equal sign, would be an equation, as opposed to an expression where the equal sign is missing. If you had just a plus 2, that would be an expression. But here we'll be solving equations. Within these equations, we have a letter, and the letter is called a variable because it can vary. It can be, different numbers. We're going to try to find the right number that it can be so that the equation is true, which means when an equation is true, the left side and the right side are balanced and they're equal to each other. All right, so it's kind of like solving a puzzle, and there's rules to solving the puzzle. And the first one here, we have a plus 2 equals 12. Our ultimate goal in a lot of the math classes is to get the variable by itself. What does a equal? And to do that, we usually get rid of what's being added or subtracted first. Now, that's not always true, and later on in the semester, we'll talk about some different things that we can do to solve. But for the most part, for the beginning of this semester, we'll be getting rid of what's being added or subtracted first. So here you have this plus 2. So in order to solve this, now obviously we know, you can solve by trial. We know that the a has to be 10 because 10 plus 2 is 12. But if it were a more obscure number that we couldn't solve by just looking at it, if you have a plus 2, you subtract 2 to both sides. Now, some people like to draw a line through here, and the table isn't exactly even, so I'm going to put a piece of paper under it so that you know that you're working, whatever you do on the left, you do on the right-hand side of the equal sign. And to begin with, drawing that line down there can help. So here you would subtract 2. 2 subtract 2 is 0. So we are left with just the a. We have our equal. 12 minus 2 is 10. So we're done. A equals 10. So in this section of 1.7, all we're doing is one-step equations. It should only take one step in order to solve. All right, so a is 10. It's a great idea to put the 10 back in to the original. 10 plus 2 is 12. So it makes the statement true, the equation true. Okay, let's look at number 6. Number 6 is saying b divided by 3. Normally in algebra, you won't see that division symbol. It would be written this way. All right. Well, just like we did the opposite operation here, we had addition, so we subtracted a 2 from both sides. Here it's b divided by 3. So to get rid of the 3, we'll multiply by 3, both sides of our equation. And these cancel each other out. So b then is equal to 9 times 3 is 27. So checking it, putting it back in as your check, 27 divided by 3 is 9. So it does check. It's a good idea to put it back in and look. All right, so here we added the opposite. Here, if it's division, we multiplied both sides to cancel that out. Here on number 7, 5 times c, what are you going to multiply times 5 to get 30? Well, most of you know that that would be a 6. 5 times 6 is 30. But if you didn't know that, in order to get the c by itself, we would divide, I'll go ahead and draw that line down here. We would divide by 5. Here you have 5 times c. To get rid of the multiplication, the opposite is division. We'll divide both sides by 5. So they cancel. And the c is by itself. That's our goal, is to get that variable by itself. So C then, which is now by itself, okay, 5 over 5, you have a 1, so we don't put our 1s in there, just C. 30 divided by 5 is 6. All right, and then you can put that back in to check it. 5 times 6 does equal 30. So we're trying to find out what the variable would be equal to in order for the equation to be balanced, just like a teeter-totter. And whatever you do to one side, you need to do to the other side. All right, so let's do a bunch of examples for this section. All right, so number 8. If you look at number 8, the variable is already by itself. We don't have to add or subtract or divide or multiply in order to get that variable by itself. So here in this case, you would just take 156 and subtract 42, and that gets you 114. M is 114. So you didn't have to add or subtract anything to both sides to get the variable by itself. So you do have to look at the equation to see, do I really need to get the variable by itself? And if it is already by itself, then you can just simplify that left-hand side or the right-hand side, depending. Now, another good thing to remember is that you can also switch sides here. So these two statements mean the same thing. A lot of times we like to have our variable on the left, but it doesn't have to be. Both of these are correct statements. All right, let's look at number 9. On number 9 here, the variable is already by itself on the right-hand side. So if you were to, that y is by itself on the right-hand side of the equal sign. So I don't need to move anything over to the other side. I don't need to get rid of any number here. All I do need to do is just take 44 times 11. And let's see, 44 times 11. 44 times 11. 484. X is equal to 484, or X is equal to 484. All right. Looking at number 10, the variable is by itself. Here, I don't need to get rid of anything on this left-hand side. All I would need to do is to take 64 divided by 4, which is 16. I just simplified. It's called simplifying that right-hand side. Didn't have to move anything from one side to the other. All right, let's continue on and look at some more examples. Looking at number 11, on the left-hand side of the equation, here I've got a 19 that I need to get rid of because I want the b by itself. Well, it's plus 19. So to get rid of that, I'm going to add a negative 19 here. Now, or you could think of it as subtracting 19. I mean, we haven't really looked at the numbers yet as far as adding a negative. So you could think of it as adding or just subtracting 19. So we come up with b is being equal to 15. There, all right, and check it. So we're going to put 15 in right here. So 19 plus 15. So I substituted that number in right there, equals 34. And that's true. 19 plus 15 is 34. So it does check. So there's my answer. B is 15. Let's do the next one. Number 12. The d, our variable, is not by itself. I have d times 15. Now we've kind of already talked about this. What we're asking for is we're missing a factor here. D represents a factor of this. To find a missing factor, we would divide. So again, thinking of it as solving an equation, if it's times, the opposite operation of multiplication is division. So you would divide both sides by 15. So now our d is by itself. So we got rid of the 15, doing the opposite operation. If it's times, you divide, And whatever you do to one side to keep it balanced, you do to the other side. So again, I'm going to go ahead and do that on my calculator. Divided by 15 comes out to be 315. Let's check it. Is this true? Does D equal 315? I'm going to put the 315 right there for the D times 15. And yes, we do. We get 4,725. So it does check. So substitute it back in, take it times 15, and you end up with 4,725. Let's look at another one. We were wondering, what do you add to 1,477? What would you add in order to get this? Well, think of it as solving an equation. We would subtract from both sides in order to find out what the H is equal to. So when you take 1,477 and subtract 1,477, you get 0. So you're left with just the H. And then we'll take 1,685 and subtract 1,477, 208. So you need to check that. If you take 1,477 and add 208, you do get this right here. Plus 208, you will get 1,685. So again, it's just a matter of doing what's called the opposite operation to move something from one side of the equation to the other side of the equation. Let's keep practicing. Number 14. I have x plus 41 equals 63. I want the variable by itself. I want to know, what do I add to 41 so that I get 63? Here, to solve the equation, just in case, you need to know these processes in case everything's all variables, you subtract 41. So if you have a plus, you'll subtract. You subtract 41. You can draw a line there if that helps. From one side of the equation, the left, over to the right. And you have to do this. If you do something on this side, you have to do the same thing on the other side. So we end up with x equaling 22. And then you would check it. You could put this right here for the x. You're going to substitute that back in and see if you get 63. And you do. So it checks. So there's your answer. All right, so in other words, there are times when we're subtracting on both sides, and there are times when we are dividing both sides. Let's take a look at this one right here. 15. I have 13 times n. So in order to get the n by itself, I'll divide by 13. So n then is equal to, I think that's even, 286 divided by 13, 22. Which means if you take 13 times 22, you should get 286, which you do. So there's, oh, I put the check mark by the wrong one. There we go. All right, let's look at number 16. On number 16, the variable is already by itself. So we're not going to add or subtract or multiply or divide both sides by something. The variable is by itself. So all I need to do is simplify here. So don't move things if you don't have to move things from one side to the other. So again, I'm going to use my calculator. 10,373 divided by 23. So F then is equal to 451. So sometimes you move and sometimes you don't. So you just have to be aware of that. And we're doing the opposite operation in order to get a variable by itself. Let's go ahead and try, let's try 17. We're adding 99 to the W. So to get rid of that, we'll subtract 99 to both sides. I didn't draw my little line there, which I can do. Ultimately, I want the W by itself. I don't want that 99 with the W on the same side. So I'm going to subtract 99. So that's a 0, cancels out. And then I take 101 minus 99, which gives us 2. So W is 2. Okay, I'm just going to switch the order here. Means the same thing. So if you were to check this, you would take 99 plus 2, and you would get 101. So it would check out. So on a lot of these, you'll either be subtracting or you could be dividing both sides by a number in order to get rid of it. And I think that's probably enough of those. I think maybe you have the idea. If not, obviously you can contact me, because I want to talk about 1.9. When we're talking about 1.9, we're going to kind of switch ideas here. We're not going to be solving, we're going to be simplifying. And when we simplify, we use what's called Pemdas. Okay, it's kind of the acronym that we use for simplifying. I just made it worse. Maybe if I put it underneath there. Oh, okay. Oh my goodness, sorry about this. All right. Well, maybe I take it out and put it back. Oh. Well, that's strange. I don't want to spend too much more time here. Let me try it one more. Oh, it's trying to focus. There we go. Sorry. All right. So with PEMDAS here, the P, and again, we're not going to be solving. This is if we had to simplify a side before we started to move things from one side of the equal sign to the other. And there are times where you just want to simplify something. There's not really an equation. It's just called an expression. There's no equal sign. When you're given, a list of things to do here, we always do what's in the parentheses first. So that's what the P stands for, parentheses. Okay, it's an R there. Doesn't look like an R. So we'll do the parentheses first, what's ever inside the parentheses. And sometimes we'll have brackets or braces as well. We'll do some of those. Then once you've done the parentheses, you do the exponents. So we're going to look at the exponents here in a minute. We'll do exponents next. Now the next two, multiplication and division, you do these from left to right as you come to a multiplication or a division. So those are done together as you read the expression from left to right. So here this is multiply or divide. Okay, as you come left to right. And the last two is add or subtract. Add or subtract as you come to them as you read it from left to right. And one of the things to remember is that you don't add or subtract before you multiply. And we'll talk about some expressions that give people some issues where you're tempted to add before you multiply. But anyway, so this is add or subtract. Add or subtract as you come to it. Oops, that's a U, guys. Subtract. All right, as you come to that. All right, so what we're going to do is we're going to talk about exponents first, just how to deal with the exponents, and then we'll look at some expressions and simplifying using the PEMDAS idea. All right, to begin with, here, that stayed in focus, yay. Okay, we're going to talk about exponents and exponential notation. So if I were given 6 times 6 times 6 times 6 times 6 times 6. And you wanted to write this using exponential notation. The base is 6, and you're multiplying the 6 together 6 times. That's the exponential notation for that. These two mean the same thing. All right. So 6 to the 6th means take 6 times itself 6 times. 1, 2, 3, 4, 5, 6. Make sure I counted that right, which I did. All right, on this one right here, we have 12, and we're multiplying the 12 to itself 3 times. So 12 times 12 times 12. So 12 cubed is how we read that. 12 to the 3rd can also be read 12 cubed. This is 6 to the 6th power. When you're doing these with My Math Lab, when you do write these down below, you'll have, and this is a little bit darker blue. So this is the template that you would want to push, and you could write 12, and then you could push this, and it would move the cursor up. All right. This right here, you're taking 1 times itself 4 times. 1, 2, 3, 4. Okay, it would be read 1 to the 4th. Okay, all right. So that would be writing a multiplication in exponential form or exponential notation. Now we're going to evaluate these. When you evaluate, okay, again, this is kind of small, so I'm going to write it bigger. This is 6 cubed, or 6 to the 3rd, and it's not 18. And there's a lot of students will do that. They'll just multiply the 6 and the 3 together, but that's not correct. You need to take 6 times 6 times 6 here is what that's equal to. So 36 times 6. So you multiply 2 of them together times 6. And let's see, 36 times 6, you come up with 216 is what the answer is. It's far from 18. So again, don't make that mistake. 6 times 6 times 6 gives you 216. Now this one right here, 2 to the 7th is not 14. Don't do that. Here, let me write it a little bit larger. That's kind of small. So it's read 2 to the 7th. 2 to the 7th means take 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. One more. 7 times. So you start out, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. 2 to the 7th is 128. Just work your way from left to right, multiplying them together. So I started 2 times 2 is 4, times the 2 is 8, another 2, 16, another 2, 32, another 2, 64, another 2 is 128. All right, number 10. This is read 5 to the 2nd is read 5 squared. So 5 squared, again, is not 10. It's 5 times 5, which is 25. All righty, a little bit easier than the 2 to the 7th, but it wasn't too bad. All right, so just be aware of that. Just watch yourself. You know, it's real easy to do, where some people will put the 10, but it is equal to 25. All righty. Okay, now let's start with our Pemdas. Now that we have our exponent idea down, okay, when we're doing Pemdas, I can write it up here. We'll practice Pemdas for the rest of the time. You're going to do what's in the parentheses. So I go to the parentheses, which is right here, and I take 9 minus 2. That gives me 7. Then I still have the 15. There's no exponents, There's no multiplication or division, but there is an addition or subtraction. So the last thing I would do would be to add those together and come up with 22. And there's your answer, using your PEMDAS idea. All right, let's look at number 12 here. Again, you do what's in the parentheses first. So you would take 25 divided by 5. You do the parentheses, that's what the P stands for. That gives you 5. 625 divided by 5 gives you, because here there's no exponents, so once you've done the parentheses, it's a good idea to look for exponents. And multiplication or division is next, and we do have a division. 625 divided by 5 is 125. And there's your answer. Okay, when you take this divided by that's 125. Let's keep practicing it. 13, P, we do that first. 6 times 3, 18. Then we have plus 11. So again, there's no multiplication or division, there's no exponents. We would add or subtract and come up with 29. Let me put those there. All right, now I'm going to turn the page over. Hopefully it stays in focus. I don't have a focusing issue. Awesome, it didn't. 39 divided by 13. So again, we're doing the PEMDAS. I can write that up here. So we'll do what's in the parentheses first. We'll take 39 divided by 13. That gives us 3. I'll keep the parentheses here. I still have my 3 as an exponent. So this is 3 cubed. All right. So we did the parentheses. Now we do have an exponent. So we will do that exponent. 3 cubed means 3 times 3 times 3, which is 3 times 3 is 9. 9 times 3 is 27. Okay, so 3 cubed is 27. Let's do number 15. I have 4 squared minus 2 cubed. And in case that's a little hard to read, I'll just rewrite it here a little bit larger. Down a little bit more. I'm always afraid it's going to come out of focus there. Okay, there's no parentheses, so we will do the exponents first. The exponents are 4 squared. 4 squared means 4 times 4. So this is 4 times 4, which is 16. Then we have a subtraction. 2 cubed means 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. And then we'll subtract them. 16 minus 8 is 8. So we did the exponents and then we subtracted. 16. We do what's in the parentheses. We have 2 of them, so we'll do them separate. This first parentheses gives us 8. I'm going to leave those around. I'm going to leave the brackets there. And the reason I'm leaving the brackets there is because eventually we're going to have negatives. And if you have a negative, you do need the brackets. It does matter if you have the brackets or not when we end up with negatives inside the parentheses. So we'll just kind of get in the habit of leaving it there. Plus 11 minus 10 is 1 to the 7th. Okay. All right, so we've done the parentheses. Now we're going to do the exponents. So we have an 8 squared and we have a 1 to the 7th. 8 squared means 8 times 8. 8 times 8 is 64. 1 to the 7th means 1 times 1 times 1 times 1 times 1 times 1. 1, 2, 3, 4, 5, 6, 7. Okay, which is 1. 1 times itself 7 times is just a 1. Again, it's really tempting to put a 7 there, you know, but don't do that. So it's just 1 times 1 times 1 times 1 times 1 times 1. So now that we've done our exponents, we did the parentheses, we did the exponents, now we'll add, we get 65. Okay, so just have the order of operations. Do things in a certain order. All right, let's look at another one here. Parentheses. So again, using our Pemdas, we do the parentheses, which gives us a 3. Now then, we have no exponents, so we'll do multiplication and division from left to right. So I will take my 18 divided by 3. That gives me 6 plus 5. And you get 11. Last thing we do is add or subtract, unless it's in a parentheses. Okay. All right. All right, let's look at number 18. No parentheses, so we'll do exponents. So 4 cubed is 4 times 4 times 4. So you have 16 times 4 is 64. 6 squared, okay, and again, that was 4 cubed, or 4 to the third. 6 squared is 6 times 6. 6 times 6 is 36. Plus, so that plus 3 to the fourth, 3 times 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay. So now then what we're going to do is we're going to work from left to right. Here, doing our adding and subtracting as we come to it from left to right. So we take 64 minus 20, or excuse me, the answer 28. So 64 minus 36, we get 28 plus 81. So we did the subtraction, and now we'll do the addition. We go in order as we see it from left to right. So we have 28 plus 81 gives us 109. Okay. All righty. We did exponents, and then we did subtraction as an addition from left to right. So again, make sure that you don't add first. You have to subtract from left to right to begin with. So here we have 64, we have to do the subtraction and then the addition in that order. Okay, let's do one more. And then we'll look at some averages. We're going to do what's in the parentheses. So we have our Pemdas parentheses, 20 for that parentheses, and 6 plus 4 is 10. Okay, now we've done the parentheses. We will do multiplication and division from left to right. So here's a multiplication that gives us 42. So I did the multiplication. Now I'll do the division. I'm not going to subtract until after I've done all the multiplication and division. So I multiplied. Now I'm going to divide. And now I will subtract. So you get 42 minus 2, which is 40. When you simplify it in order. Now, there's one other thing I wanted to talk to you about where some people will add before they multiply. And that would be, as an example, I'll just do it right here. If I had 5 plus 2 times 10 minus 7. Okay. In something like this, you do the parentheses, and that gives you a 3. Now, you will not add these together because this parentheses means to multiply. So what I have right now is 5 plus 2 times 3. We talked about that before, the parentheses, when numbers are separated by this parentheses only, it's multiply. So do not add 5 plus 2 until after you've taken 2 times 3. Now 5 plus 6 is 11. So just kind of be aware of that. It's real tempting to get a 7 here. But again, make sure that you multiply before you add the 5. Okay, all right. So our next thing we're going to look at is how to find an average, given some numbers here. So we'll just kind of probably just pick one of these. I think all you need is one example. To find the average, you take the sum and then you divide by the number of items or the number of numbers that you have. So here we have 14 plus 24 plus 55 plus 19 divided by 1, 2, 3, 4. All right. One of the things you have to make sure you do is that you find the sum first, and then you can press your equal and then divide by 4. Because if you put in your calculator 14 plus 24 plus 55 plus 19, and then you just press the division, it knows PEMDAS. So your calculator will do the PEMDAS. It'll take 19 divided by 4 only, because it will do division before it does the adding. So you need to make sure that if you do it this way, you either have, a key that will separate it like this, or you take and you add these together, which I'm going to do. 14, I don't have that done yet, plus 55 plus 19, that you take 112 divided by 4, and you get 28. And again, make sure that your answer makes sense, because if you're finding an average, the average will always be between the high and the low. It'll always be between the high and the low. And if it's not, then you've done something wrong. So you can always check, does my answer make sense? I guess it'd be $28 since those are in dollars. But you add them up and divide by how many you've got. That's how you find the average. And we'll be doing the average in a bunch of these different sections. Okay. All right, let's look at one. Well, maybe we'll just do one of these right here. I don't want this to run too long. Here you have multiple parentheses, actually. So here we have parentheses, and then this is called a square bracket. This square bracket is a parentheses. They're just using 2 different types of parentheses to make it look better. And this outside one is actually also a parentheses. It's called a brace. It can also be called a curly bracket or a squiggly bracket, but for the most part, we'll call it a brace on the outside. But they all are just different ways of writing a parentheses. So when you're doing something with multiple parentheses, you work from the inside out. So you would start here, 48 divided by 16, and that gives you what, 3? Okay, so you did the inner one. Now we're going to look at the bracket, and we're going to take 21 divided by 3. That gives you 7. Then we'll take 14 and subtract the 7, because we're working inside the brace now. 14 minus 7 is 7. So we have taken care of all of this brace here, all of these braces, brackets, parentheses, by working on the inside out. We started on the inside and got 3. Then we did the next one, the brackets here, the square brackets, 21 divided by what we got here, which was 3. That left us with 7. And then we took 14 minus what we got here, and 14 minus 7 was 7. So you have 32 divided by 4 plus 7. 7 is what we got here. Now you'll do your division. 32 divided by 4 is 8. 8 plus 7 gives you your 15. So again, you work from the inside out when you have these multiple brackets. Let me see if there's another one that's kind of harder. I don't see. Well, we could do maybe 24. Okay, that one looks kind of tough. Let's do 24 just in case. That was a little bit confusing. All right, we've got these braces here. You know, we've got brackets, and inside the brackets, we have this parentheses. So I'm going to simplify everything in here. Then I'm going to simplify what's in here, and I'm going to multiply the two together, because then we'll have to do everything within the brace. The last thing we're going to do is multiply by 3. I hope this isn't too confusing for you. So let's take, and working on the inside of this, here we do PEMDAS, we take 9 minus 4. I think I might erase this, so we don't have too many marks here. Then within, we did this parentheses, now within the bracket, we're going to do division and then do adding. So here we'll take 25 divided by 5, which is 5. So we did this, and then we'll add 9. And we're still inside of our square brackets. Then we'll take 5 plus 9, and we have 14 inside the bracket. Moving over to here, we have a times. Inside, 11 minus 8, let me kind of straighten that out there. 11 minus 8 gives us 3. So we have a 3. Now here, oh good, we have a plus 4. Here's our another brace right here, and we have the 3 outside. So inside our braces, we'll take 3 times 14. That gives us 42. Plus 4. We'll have fun. Then inside the brace, we'll take 42 plus 4. That gives us 46. And now it's 3 times that right there. Okay, which gives us, let's see, 18, 138, I believe. Yeah. When we multiply those two together for your answer. So recapping, I worked on the inside. So I had this bracket here. On the very inside was this. And then I took 25 divided by that and get 4 plus 9. So now I'm working inside of this bracket. I'm still working inside, I get 14. Then I go over to this parentheses. And I know that I'll be multiplying these two together. Now here I have, inside here I've got plus 4. So I'm going to multiply. Ooh. Yes, because that's inside the bracket. So then I multiply, I get 42 plus 4, 46. So all I did was simplify everything in here. And then times 3, 138. Okay, all right. Well, I hope that helps. Just kind of, you know, take your time and be neat about it. And I think you guys will do great. And you know, if you need any more help, just please don't hesitate to ask. All right, thank you.